Hello everyone, this is part 3 video on past year NEET questions from the chapter polymers. Now those who are looking at this video can also take a look at the previous two parts so that you will have continuity of questions. We'll start with a question that has come in the year 2005. The monomer of the polymer is. So generally these kind of questions, right, they will be given for the addition polymers where the monomer, respective monomer will be having the unsaturation. Okay. Now if you look at the polymer, right, what we need to do is we have to identify what is the repeating unit. So here they have given us a plus, means there is a possibility for the chain getting elongated. Okay. So what is the repeating unit? Here you can see this is the repeating unit. So all we need to do is just take out the repeating unit as it is. So we have taken it out. So once we take it out, we will see that these two carbons will be now having one valency deficiency. We will account for that by having an additional bond created. That's it. This is the monomer. So when we polymerize this monomer, you will be getting a homopolymer. So the homopolymer will be the one that they have given in the question. So these kind of questions will be generally asked for the addition polymers. So what is the answer for this? It is option A. So we just have to take out the repeating unit and account for the valency deficiency by creating the additional bonds. Thereby you can see, and in the monomer, right, we'll have the unsaturation. So that is the method to answer these kind of questions. Next we have a question that has come in 2004. Which one of the following is a chain growth polymer? Chain growth polymer means we'll have chain growth polymerization happening either by the free radical mechanism or by the cation mechanism or by the anion mechanism. So one such very important example is the formation of polystyrene. So what is styrene? Benzene will have CH double bond CH2, that is styrene, right? So when styrene is attacked by the radical, any free radical, that will be able to give rise to another radical. So that is the initiation step. Now this radical, when it is attacking another styrene molecule, will have the chain propagation, chain length will increase. So as long as this radical is going and attacking another styrene molecule, we will see that the chain length keeps on increasing. And the culmination will be the termination step. So when this radical, right, is attacking another radical, so radical plus radical will give rise to molecule, that is the termination step. So this way we will be able to achieve the formation of polystyrene, which happens through free radical chain growth polymerization. So the correct answer for this is option C. It's a very important example, option C, which is the polystyrene formation. Next we have a question that has come in 2003. Acrylon, this is a commercial fiber from polyacrylonitrile PAN. It's a hard and high melting material. Which one of the following represents the structure? So what is PAN? It is the homopolymer of acrylonitrile, right? So what is acrylonitrile? CH2 double bond CH CN. So when we have the polymerization happening, so we will see that there will be the addition bonds formed, and as a result of it, right, the repeating unit will be, this will be the repeating unit. So the correct answer for this is option A, which is CH2CHCN. That will be the repeating unit of polyacrylonitrile. The commercial fiber made from this is acrylon. In fact, Orlon is another commercial fiber of polyacrylonitrile. Next we have a question that has come in 2003. Which one of the following monomers gives polymer neoprene on polymerization? What is neoprene? Neoprene is also called as polychloropene. So from that itself we will be able to know the answer. So what is the neoprene? It's a homopolymer of chloroprene. So what is chloroprene? It's a 4 carbon chain. Carbon 1 and 2 will have a double bond. Carbon 3 and 4 will have a double bond. Carbon 2 will have a chlorine. That is chloroprene. Okay, so we can remember the IUPAC name also, but this is even more easier method. Okay, so when it undergoes addition polymerization, this is also addition polymerization, it will be able to give us the linear chain of neoprene or polychloroprene. So how this gets formed, we have already seen in one of the previous question, but we'll anyway look at it now. So CH2 double bond C, Cl, CH double bond CH2, this is one unit. We'll take another unit, CCl, CH double bond CH2, like that. Okay, so this will keep repeating. So when we see the addition bonds being formed between the monomer units, right? So we'll have the addition bonds formed here. So here we'll have addition bond, here addition bond, like this. The double bonds between the carbon 1, carbon 2 and carbon 3, carbon 4, they will be removed. As a result of it, what happens is carbon 2 and carbon 3 will be now one valency short. Same in each repeating unit, right? Carbon 2 and carbon 3 will be one valency short. They will form the additional bond. So the repeating unit will be what? Will have chlorine as it is on the second carbon, but the double bond will be between carbon 2 and carbon 3. In fact, they have asked questions on the structure of the neoprene also. Okay. So, but here the question is what? The monomer. So monomer is chloroprene, right? So how do we remember chloroprene? 4 carbons, 1, 2, 3, 4. Carbon 1, carbon 2 double bond. Carbon 3, carbon 4 double bond. And chlorine will be on the second carbon. That is the monomer for the neoprene rubber or polychloroprene. Next we have a question that has come in 2002. The monomer of, they are giving us the polymer with clearly indicating what is the repeating unit. Sometimes they might give us a chain and we will have to fetch what is the repeating unit, but here clearly they have given us the repeating unit. All we need to do is just take out the repeating unit as it is, CH3, CH2, CH3. Now we will see that these two carbons are one valency deficit. We will form the additional bond. That's it. So this is the monomer. So generally these kind of questions, right, will be asked only for the addition polymers. Now we'll see, we'll have to name it because in the options, right, they have given us the names. So the unsaturation is there. So we'll take the chain that contains the double bond. So 1, 2, 3 like this. So second carbon we have methyl. So 2-methyl prop 1-ene. That is the IUPAC name. But the thing is, in case of a 3-carbon chain, right, with a double bond, if the double bond is here, we will start the numbering like this. If the double bond here, we will start the numbering like this. So which means always our double bond will be given numbering 1. So that is why the number 1 is actually redundant here. So that's why we can also write it like what? 2-methyl propene. So the correct answer for this is option 2. Which of the following is not correctly matched? So we have to identify which of them is not correctly matched to the respective polymer. So neoprene, already we talked about it, right? It will be 4 carbon, 1, 2, 3, 4, second carbon chlorine and double bond between second and third carbon in the repeating unit. That is correct. Nylon 6,6. It is formed by the condensation of the hexamethylene diamine and adipic acid, right? So between two NH groups we'll have 6 carbons that will come from the hexamethylene diamine part, and between two CO groups we'll be having 4 carbon units. Okay, that is coming from the adipic acid. So these two are what? The monomers. It's a copolymer. It's also example of condensation polymer because this happens because of the removal of water molecule. I think we have seen this in the couple of previous questions also, but this is also correct. So nylon 6,6 is correct and neoprene is correct. Next they have given us terylene. So what is terylene? So terylene is also called as what? Dacron. Terylene can be commercially also called as what? Dacron. So what is terylene? When ethylene glycol, which is an alcohol, and the terephthalic acid, which is an acid, they undergo condensation polymer by the loss of water molecule, we will be able to get a polyester. So what is this? This is the terylene. So the structure, right, will have ester in it. So O CH2 that is coming from the ethylene glycol part. Then we will have the COO, ester group should be there. But in the structure that you see here, right, they have given us what? CO only. Ester group is not present. So that is a wrong one. So the structure that they have given for terylene or Dacron is what? It's a wrong one. So it should be actually an ester. So terylene is example of polyester, right? But they have not given us the ester structure. That is why the one that is not correctly matched is what? Option C is not correctly matched. PMMA, it is a short form for polymethyl methacrylate. Okay, so this is a homopolymer of methyl methacrylate, and that structure is the correct one. So the one that is not correctly matched is terylene. Next we have monomer given, and we have to find out what is the polymer. CF2 double bond CF2 is a monomer of, what is this? CF2 double bond CF2, it's a monomer. When it undergoes polymerization, we will get a homopolymer. So what is this homopolymer? Polytetrafluoroethylene. So tetrafluoroethylene, when it is undergoing polymerization, homopolymerization, it's an addition polymerization also, because the tetrafluoroethylene has got unsaturation. We can see that this is the repeating unit. What is the repeating unit? CF2 bond CF2, that is the repeating unit, and this is also commercially called as Teflon. So Teflon has got some very interesting applications, including things like this is also used as coating for non-sticky pans, etc. Next we have a question that has come in the year 2000. Which compound forms linear polymer due to hydrogen bonding? So now we know that the hydrogen bonding strength, right, will depend upon what is the electronegativity of the other element attached. Like if you look at it, right, hydrogen bonded to fluorine will have the maximum electronegativity difference. So that is the reason why hydrogen fluorine, that bond will be able to give us the hydrogen bonding with highest strength. So in fact HF, right, will be able to form a linear polymer like this, and these dotted lines are representing what? The dotted lines represent the hydrogen bonding. The correct answer is option C. Next we have a question that has come in the year 1999. Natural rubber is a polymer of. So what is natural rubber? It is the polymer of cis form of isoprene. Okay, so cis 1,4-isoprene, when it is undergoing addition polymerization, it will give us polyisoprene. That is what is the natural rubber. Okay, so natural rubber is obtained from the latex of the rubber tree. So what is the answer for this? It is isoprene. Next we have a question that has come in the 1999. Terylene is a condensation polymer of ethylene glycol, and already we have seen this, right? What is it? Ethylene glycol and terephthalic acid. They undergo condensation polymerization by the loss of water molecule, and we will get a polyester. So in fact the previous question that we saw was about the structure. So the structure they gave was incorrect one. Okay, so what is it? The terylene, it can be also called as what? Dacron. So these are the commercial name, and the polyester form, right, is what we call as polyethylene terephthalate, in short PET. This is what used in the PET bottles. Okay, the other two commercial names for this is terylene as well as dacron. So the correct answer for this is option D, ethylene glycol along with terephthalic acid. It will be able to give us the terylene. Next we have a question that has come in the year 1997. Which one of the following is used to make non-stick cookware? I think already we mentioned about it. The non-stick cookware, right, basically comes from the coating of Teflon. Teflon is what? Polytetrafluoroethylene. So the non-stick cookware, I'm sure you will be seeing it in our households, the pan or the dishes, etc., right? So the coating is basically from the Teflon. So what is the answer for this? Option B, which is polytetrafluoroethylene. So the commercial name for this is Teflon. Next we have a question that has come in the year 1995. The bakelite is prepared by the reaction between. So already we have talked about it in, I think, the first part video we have mentioned about it. So bakelite, right, it's a example of cross-linked polymer, which also makes it a thermosetting polymer. Okay, so bakelite is prepared from the monomers phenol and then formaldehyde. First, the normal polymer chain of novolac. So the novolac, when it undergoes the cross linking, because you see that on the phenol chain we'll have active sites. So the active site, when it is undergoing the cross linking, right, cross linking will be because of the strong covalent bonds. So everything in a cross linking polymer, it's a three-dimensional network, right? Everywhere it is the covalent bond only. So that is the reason why these cross link polymers will be hard and rigid. So this is what is the bakelite. It's a 3D structure formed by the cross linking of the novolac. So the monomers, right, the starting materials are what? Phenol and then formaldehyde. So what is the answer for this? It is option A. That is why the bakelite is also called as the formaldehyde resin polymer. So these low molecular weight substance like formaldehyde, right, they will be able to fuse well and form the polymer. So this is about the part 3 video, and with this we have completed the discussion of past year NEET questions from polymer chapter. So make sure that you go through all the relevant examples, and if required, wherever you feel that some additional review of theory is required, you can go and accordingly prepare, and wish you all the very best. We'll see in the next chapter.